So now I thought it would be a good idea to kind of take everybody through the workflow for the assignments, kind of from step A to step Z. So really what you're getting out of this video right now is a freebie on assignment 1. So I'm going to show you exactly all the steps you need to do to get the code onto your local machine to start working on assignment 1. We'll go through the steps of putting the functions together, committing code to the Git repository, and pushing that code back up to the get back up to GitHub, and then kind of show you all the little ins and outs. So as long as you follow along with this video, you should be set for assignment 1. Right, so at this point I'm kind of expecting you to have already accepted the assignment invitation link, which is found in the D2L assignment section. Right, so you click that link, you say you want to accept the assignment, and then GitHub will give you a link to your assignment repository, which should look pretty much exactly like what you see on my screen right here, right now. So right now, this is, kind of just a template repository. I've given you the assignment instructions. I've given you some starter code inside of source, and then I've also given you some tests that you can run once you think you're mostly complete with your assignment to verify that everything's functioning mostly the way that it's supposed to be. Right, so right now this code only exists on GitHub, right? It's out there in the cloud, it's not on your local machine. So step 1 is to actually get that code on your local machine. And to do that, what you're going to do is click on this clone or download button here, and what you want to do is copy this link. Don't hit download zip, because if you download the zip file, you're not going to be able to edit it and submit things back into GitHub. You can only submit things back by first copying this link. So we're going to control copy, and then we're going to go find ourselves a terminal. And once you have a terminal, what you're going to do is you're going to type git clone, and then you're going to paste that link into your terminal, and that's going to let us clone the repository down to our local machine. So we're going to get enter, it's going to say cloning into this specific folder, and then it's going to download everything. Right, and by cloning, this sets up a whole bunch of settings that allows us to go ahead and submit code back up to GitHub once we've kind of finished one of the functions or one of the features that we want to work with. Right, so now everything's put in this folder for us. So I'm going to do cd csc 300, and there you go. You're going to see the exact same folder structure that we see on GitHub here, right? Now the code is on our machine locally, and we can start editing it. So what I'm going to do is I'm just going to open a folder real quick, just so we get a little bit better visual representation. So we open that, and my terminal disappeared. For those of you who are curious what I'm using right now, this is just Visual Studio Code. It's a pretty handy little editor, pretty powerful with a lot of different features in there. So the first thing I thought we would do is just kind of take a little tour of the files I've given you so that you kind of understand the purpose of each of them and what you need to complete or what you don't need to kind of complete, as this is kind of the format that you're going to be seeing for pretty much all of the assignments in this class. Right, so if we look under the source folder here, we can basically see we have a command.txt, dll.hpp, main.cpp, makefile, and node.hpp. Right, so we're just going to kind of take a quick glance at all of these, and I'll show you exactly what they're doing. Right, so the first file we're going to look at is basically main.cpp. This is the main entry point into our program. You can think of it as the driver that's going to pull in our custom class that we're writing and is going to make use of it. So another way to think of this is also that this is the client or the user of the class that we're writing. Right, so the whole idea of all of these assignments is we're going to be creating data structures that provide an interface that someone's going to use. And that someone, in this case main.cpp, doesn't care how we implement it. It just cares that it gets the expected behavior from the functions it's calling. Right, so overall this file is not super long and not super complex, but we'll take a look at exactly what it's doing. Right, so we've got some includes up here. We've got fstream, that's so we can open and read from our command.txt file, which is how we specify and tell main what to do. We have this include C standard defs. So this is a header file which includes a bunch of definitions that were in the C specification but weren't necessarily carried over directly into the C++ specification. So basically we include that so that we can get access to null, basically. Null itself, as in like this, does not exist in C++. Instead we have this null pointer type, but I like using null. So we're going to go ahead and just use the C standard def header. Then we include IOStream so we can get input, screen input and output. And then we include dll.hpp, which is the header file / code file for the class that we actually want to implement to complete this assignment. Right, so basically main, it's our normal main entry point, so we declare a list, and remember the whole point of this assignment is to create and implement a doubly linked list, hence the DLL name. So we create an instance of our doubly linked list class, and if you note the braces here, we're saying that this class is going to basically hold integer numbers. And if you remember from the templates video and the STL video, this basically means that the class we're writing is a templated class. Basically meaning that we can use generic placeholders in place of types. So we can make our list be kind of actually useful and hold just about any different type. We can hold integers, we could change this to floats, we could change this to ints, etc. It doesn't really matter. But we'll take a look at that in a second. Okay, then we have this node class that we are making an instance of, or I'm sorry, a pointer to that node class. And again, this is a templated class, and this class is laid out in node.hpp, which we'll take a look at in a second as well. Right, so the node is basically going to be the basic building block of pretty much most of our data structures. Right, so our doubly linked list is made up of nodes, and then there are various operations that we can perform on those nodes, which are already done for us in node.hpp. So those are our main types. So then the big thing that basically happens is we check to see how many arguments were passed into our program. We are expecting at least one additional argument besides the name of the program, right? So basically we're saying call our program a1.out and then pass it the path to the command file that's supposed to read. If that's not there, bail out. If it is there, we go ahead and we open that file and then we start reading from that file. And that file is just a series of numbers, right? A series of numbers in two columns, where the first column indicates the function that we're ultimately calling, and the second number indicates a parameter that may be passed to that function. So for instance here, we read one number into the variable command, and then we have a switch statement on that command. If that number in command happens to be a 1, we know we want to perform a prepend function on our doubly linked list. But of course, in order to prepend something, we need to know what we're going to prepend into the list. So before we call prepend, we go ahead and read another number from the file. All right, so after that, we call mylist.prepend, pass it the argument, and then we're good to go. And then so on and so forth. We check if it's a 2. If it's a 2, we call append, 3 remove front, 4 remove back, etc., 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 all the way through basically 9. So in essence, our doubly linked list class is exposing 9 different functions that the user could call. And those 9 functions are what we are responsible for completing for this assignment. And if we want to check what that command.txt file looks like, it just looks like this. Very straightforward. 2 columns of numbers. First number indicates what function we want to call. Second number indicates a parameter to that function if the function needs a parameter. So for instance here, 1 was prepend, and we want to prepend 1. 8 is get front, I believe, which takes no parameter, and 9 is get back, if I remember correctly. Right, so if you want to test various combinations of things in your program, this is the file you can go to edit in order to kind of test different combinations of things out. This is by no means a comprehensive test file, but it's enough to test some very basic functionality. After that, we have our make file, which we will use to go ahead and build our programs. Nothing too fancy here. Basically, we're just calling G++ on our main.cpp file. Nothing too crazy. And then the first serious file we can kind of take a look at is the node.hpp file. Right? Before I get too deep into this, you've probably seen .cpp files and .h files. One's a header, one's the code implementation. But we also have these .hpp files, which contain both header information as well as actual implementation code. So in most normal cases, we would put just the class definition in the header file and then create a separate C++ file which has all of the actual implementations of those functions in it. But in this case, for this assignment, we're just going to mash them all into one big file that gets included into everything. It's nothing too complex, and we're just basically doing it as a side effect of the templates that we're using. Right, so again, this file defines and implements our node class, which is the basic building block for basically all of the data structures we're going to make in this class. So what we have to support that is basically a templated class. So we can think of the node as a wrapper, and the node can support basically any type of data we would want to store in it because of our use of our template. Right, so for our template we have t data, right? So our data could be an integer, it could be a string, could be an address, doesn't really matter as long as it's there. And then we have two pointers, one pointer to the next node in the list and another pointer to the previous node in the list. Right, nothing too crazy. The one catch here is that all of these are in the private section of the class, meaning the user can't directly access them. So in order to kind of abstract everything away a little bit and give us some basic protections and basic C++ uses, basically we have this set of public functions, which is what we will use to access and set different pieces of data on our class. So you can see here we have a set data function which inserts data into the node. We have a get data function which returns that data that's stored in the node, set next, set previous, etc., etc., etc. Excuse me. And for our cases, this class is already fully implemented for us, so you're not going to have to worry about doing anything in this file. This file is just here for you to review and kind of see the functions that are available to you as you're drafting up your DLL, your doubly linked list class, as well as kind of how those different things are implemented. Right, and then the main file for this assignment, and in fact the only file that you're going to be editing for this assignment, is the dll.hpp file. And this is the file which is actually going to define and implement our doubly linked list class. Right? As I had noted before, this is a template class, so it can host any sort of data inside of the linked list. It could be strings, chars, whatever, doesn't matter. It could be instances of other classes for all we care. All that we need to know is that our generic type name that we're going to be using is T. That's all that really matters. And as with any linked list, we basically have a head of the list and we have a tail of the list. So these two pointers are always going to be pointing at the first and the last elements. That's the whole point of this. And then after that, in order to support that, basically we have a whole slew of functions which are going to be the interface that we're exporting to the user. Alright, so as you can see down here, I have the prototypes for the functions listed out, as well as descriptions of what the function's supposed to do, descriptions of any parameters that function takes, as well as descriptions of what the function is supposed to return if it's going to return anything. Right, so here we have our constructor. It just initializes a new empty list. We have the prepend function, which adds new data to the that's supposed to be beginning of the list. typo there, to the beginning of the list, and then the parameter it takes is the data that's going to be appended. We have the append, which is supposed to be the end of the list. Wow, I couldn't type apparently to begin with. After that, we have the remove function, which searches the list and removes the node that we're searching for if it exists. The parameter it takes is basically the data that we want to search for that will be removed, and in this case, this returns a true or a false depending on if the value that we wanted to find and remove was actually in the list or not. So if we found the data that we want to remove and it was successfully removed, we return true. If not, we return false. Then we have a remove front and remove back functions. Those are pretty self-explanatory. Either remove the first element in the list or the last element in the list. We have a search function, which basically searches the list for a given piece of data. And then here it's important to note that if we find that specific node containing that piece of data that we want to get back out, we return a direct pointer to that node. Right, so that's what this little hoopla means here. We're just saying that if we find it, then we return that pointer to that node back to the calling function. Then we also have a get front and get back functions. Again, those are both pretty self-explanatory. They return the data that's at the front of the list or the data that's at the back of the list. And then we also have a print function that we can just use to kind of verify that our list is being constructed how we think it's being constructed. So then following that, we basically have the space where we can start implementing our functions. As you can see here, I have placed, just wrappers or more or less empty skeletons of all of the various functions. And this is where we are going to go ahead and start implementing our functions and showing you, kind of how we're going to go about developing this and the steps we need to take as we go through our process so that you can successfully complete this assignment and successfully submit it back to GitHub.